Why do people go bald?
Why are baboons' bums red?
What's a light year? Why do leaves go brown in the autumn? Why do monkeys like bananas? Why do some things glow in the dark? Why do animals not understand humans? Why do my receipts fade after a year?
Don't know the answer? Ask the Naked Scientists.
Hello and welcome to this week's Ask the Naked Scientists with me, Sue Marchant, and Dave Ansell. Let's welcome to our studio Dr. Dave to find out what's new in the land of science.
Good evening, Sue.
Is there anything starting? There was something exciting the other night about up in the universe, wasn't there?
Oh, there's been a couple of things. The one I wanted to talk about was possibly a subtle one.
Yeah.
That astronomers have found water on a planet outside of our solar system.
Wow.
This is 63 light years away, which is about 600 million kilometres. So a fair distance. And the really scary thing is how they managed to do it.
Now, just thinking that. The
problem is that you've got a planet going around a star, and in fact this planet is on a really, really close orbit. It orbits around its star just over 2 days. So it's really, really close to the star, and the problem is the star is billions and billions and billions of times brighter than this planet. So how on earth can you tell it's there? What they did was they managed to find a planet which went behind the star once every orbit. And they've looked very closely at its spectrum. This is like all the different colours of the rainbow in the star. And noticed how it changed as the planet orbited it. And looked at the difference between when the planet was there and when it was behind the star. You can't actually see it going behind, but you can tell it's gone behind because of the change in brightness of the star. And they looked at the two differences, subtracted the two, and they got the colours of light which the planet itself was emitting. This was all in the infrared light because the planet's really quite warm. It's between like 930 degrees centigrade and 650 degrees centigrade in the cool part. So it's pretty warm. It's glowing away nicely like a lump of iron would do at that temperature. They're just looking at this light. The weird thing was they looked for water on the same planet 4 or 5 years ago and they couldn't find any.
Oh.
And when they came back to it and had another look for a bit longer, they suddenly discovered there was lots of water there. And what they think's happening is that this planet is really near to the sun. It's really hot, and you get really big storms there. And sometimes they're lifting up water into the upper atmosphere that you can see. So at the moment, there's obviously a big storm going on, which is swirling water vapour up at the top of the atmosphere. But most of the time, it sort of sinks down. The other time they looked, it sunk down, and they couldn't see it. So it's just a fascinating way you can use so little information to find out so much about a planet billions and billions of kilometres away.
Just amazing. Send Jim up from Star Trek, he'll sort it out. Now then, we have lots of questions here. Andrew in Cambridge has asked, Dr. Dave, how does superglue work?
Well, superglue is there's various different chemicals on them. All of them, they're all called cyanoacrylates. These are little molecules with some carbons and nitrogens and oxygen in them. And normally they'll sit there on their own, bimbling around perfectly happily. But if you get a very small amount of water added to them, and there's enough moisture in the air, lots of water or just on dry skin, then this will trigger a reaction which makes these little molecules all glue together. So one sticks to another one, sticks to another one, sticks to another one, sticks to another one, into a big chain, and forms what's called a polymer. That just means lots of MERS, lots of monomers. Yes. So you just get a big long chain, and all these chains kind of all tangle together and form a solid lump. And because superglue is so runny to start with, it kind of runs into all the lumps and bumps in the material the two materials you're sticking together, and gets very close to it. And when two objects are incredibly close together, then they tend to be attracted to one another. And so the superglue will stick to both sides, and it's now a solid lump, so it sticks things together.
All right, well, thank you very much for that. I think that's answered that one. Now, one here that came in from Mark the Storman, who said, I've been reading on the internet we will have an extra second added to 2008 due to the Earth's atomic clock needing updating. And the modern commerce sat-nav needs this to happen because they rely on specific timing for the satellites, i.e. a fraction of a section wrong on a sat-nav satellite and it could put you out of position by 30 metres as opposed to the usual 30 centimetres accuracy. I think I understand why sat-navs need to be accurate as they beam signals, etc. to measure position. But can your scientist, Chappette, or Chappie, explain why the Earth slowing down should change time?
Time can get warped and pass at different speeds if you're in different places, if you're moving at different speeds. If you're sitting down on Earth, time goes ever so slightly slower than it would be if you are up outside the Earth. The further away you are from a big mass, the faster time goes. But the real thing we're talking about with this is nothing to do with Einstein or Newton or whatever. It's basically the Earth is slowing down. And people like midday to be when the sun is above our heads.
Yeah.
And because the Earth is slowing down, if a day continues to be exactly 24 hours and the Earth slows down, then the Earth doesn't quite get all the way round in each what we call a day, and it slowly slows down, and so it gets behind and behind and behind. Every few years, they have to put in an extra second. So as midday is when the sun is directly above Greenwich. The actual effect that would happen if you didn't do this, it would basically mean that all the time zones would slightly warp, and the centre of all the time zones would no longer be over Greenwich, it would be over somewhere else in London, or if you left it long enough, it would slowly move into France or whatever. Basically, the place where the sun is midday, on average, directly overhead at midday, would no longer be in Greenwich, and it would slowly move because the Earth is no longer synced up with time anymore. There is actually a big movement to try and get rid of all these leap seconds for the actual time which scientists use and things like sat-navs use, because it's a right pain to deal with, because you've got to write special computer code which knows when these leap seconds are coming, and they're not actually that predictable. So what there's a lot of people wanting to do is have two different sets at two different times, one of them which is kind of the standard time which scientists use and anyone who's writing computer programs use, and another one which is the one which everyday people use, which is to do with where the sun is in the sky. Slowly, you just have a difference between the two, which slowly changes. And it would just make life a lot easier if they did that. Because otherwise, if you're trying to work out how many seconds it's been since you took a picture of a star 20 years ago, it's a right pain, because you've got to include all of these leap seconds all over the place, and you've got to be sure that you've added them in last time and took them out in the right order.
What would you prefer to have, Dave, as a scientist?
Definitely, if I was doing any calculations or anything, it would be a lot easier if you had a big number which was just the number of seconds since a certain date, and you just kept adding them on, because then if you want to know the difference in 2 times, you just subtract 2 numbers and it's really easy. Otherwise, life gets difficult. Dealing with time is a pain.
Yeah, makes sense to me. Now then, Tesco Tom says, how do they make fishing line so fine, Dave?
I don't have any direct knowledge of how to make fishing line. I've never been to a factory. I mean, to be honest, actually, fishing line is quite thick compared to other things which they spin from molten plastics. I mean, things like the fibres you make clothes out of, the fibres my fleece is made out of, they're polyester, which is been reacted together and then sort of squirted out through very, very fine holes, which produces very thin fibres. So I think probably the way they make it gets a load of molten plastic of some form. Exactly how you get that will depend on the plastic you're using. And then squirt it through a small hole, and then the fibre which comes out will be the size of the hole. And you just put it on a reel, and you get it long enough to let it dry out and solidify. And then you just wind it onto a reel, and you have a line. Basically like those little kits, I don't know if you remember them, we had plasticines type stuff and squirted them through little holes and produced a long kind of snake-like shape thing.
We love plasticine. Thank you, Dr. Dave. Now then, Mike has sent an email in. How big is the black hole at the centre of the galaxy, and how long before it swallows up our sun? And, he goes on to ask Dave, do we know what the mass of this object is compared with the total mass of the galaxy? Ooh, good one for you, Dave.
Very good question. Okay, the way they work out how heavy things like black holes are is by looking at the orbits of a star. Basically, the more mass, for something which is orbiting at a certain distance away from any object, if it's a black hole, a normal star, the Earth, the Moon, whatever, if you look at how far, there's a relationship between how far away it is and how long it takes to orbit. So if the more massive it is, the quicker it will get round the quicker the orbit is for the same radius. Yeah. So basically they've looked at all the stars around the centre of the galaxy and looked at how they're orbiting. And from that, and knowing how much they all weigh, from that there must be a big mass sitting at the centre, which is causing all these stars to whip round very quickly, much quicker than they would do otherwise, and orbit round the centre of the galaxy. And they reckon that the mass of this black hole is somewhere between 3.2 and 4 million times the mass of the Sun. So quite a hefty object, really.
So it could swallow up the sun then, in that case?
It could certainly swallow up the sun if the sun was in the right place. The thing is, it's actually quite small. The black hole itself is only about the 10th of the orbit between the 10th of the radius of the Earth's orbit. So it probably would all sit within Mercury's orbit in the solar system. It will be swallowing matter very slowly. The thing is that I don't know if you've ever played on a roundabout when you're a kid.
Yes.
If you got something spinning and the galaxy's spinning, if you try and climb into the centre of that roundabout, the roundabout spins faster and faster and faster.
Uh-huh.
It's called conservation of angular momentum. And basically, if stars try and move closer to this black hole, they're going to spin faster and faster and faster until eventually they're spinning fast enough to orbit. So for a star to actually fall into the black hole, it's got to lose all of its movement energy. It's got to lose all of its angular momentum. And you could do this by, if you had two stars orbiting in opposite directions, they crashed into each other, exactly stopped, then fell straight towards the black hole, then they could fall in. But normally it's almost impossible to lose all of that energy, so they'd almost inevitably just slightly miss on each orbit. And so unless there's something which slows them down, they're not actually going to get pulled in until they get very, very, very close. So we're hundreds of millions of light, I think definitely hundreds of thousands of light years, I think hundreds of millions of light years out from the centre of the galaxy, definitely tens of millions of light years out from the centre of the galaxy. So I don't think, definitely no time soon, unless something very strange happened to the sun's orbit around the galaxy, we're going to get anywhere near the galactic centre for billions and billions and billions and billions and billions of years. So nothing to worry about in our lifetimes.
Now then, Mick has sent a question in. He says, Dr. Dave, I watched the film Perfect Storm. Oh, is that with George Clooney? And I think it is. Is it possible for 100-foot waves to be generated, and how do they react at sea?
There are a couple of ways you can get a 100-foot wave. The one which probably people are most used to are tsunamis. These are big waves created by earthquakes. Basically, you have an earthquake with one bit of the ocean floor trying to move downwards, and the other bit trying to move upwards, and all of a sudden they jump. And all of a sudden you've got a huge amount of water lifted by a couple of metres on one side and dropped by a couple of metres on the other side, and you've essentially just made yourself a wave. And these will travel very fast across the ocean floor, and when they reach the coast, their height will build up and up and up. Actually, in the middle of the ocean, they're quite small. They can only be a foot or two high. They're just moving very, very quickly, and ships wouldn't notice them. Possibly feel a bit of a jolt, but that's all. But when they reach the coast, they can get very, very big, easily 30, 100 feet high. But I think the waves he's thinking of, you get freak waves in really big storms. These normally occur when you've got a load of waves coming from lots of different directions and all adding up and forming so you've got lots of waves coming from the north, south, east and west, all kind of jumbling up and forming a very messy, choppy sea. And if you happen to get lots of waves all kind of converging onto one point, then they can kind of collide with each other and build up into one massive wave. It only tends to last a few seconds, maybe a few tens of seconds. But there are definitely documented cases of huge waves. I think it's sort of been 26 metres, nearly 100 feet, ones crashing into oil rigs, 30-metre ones wiping out ships. They think a lot of ships which are lost in the middle of oceans could be due to these freak waves. There have definitely been some big passenger ships which have been hit, and one of them got almost sunk by it in the Southern Ocean. Another one got hit and just about survived and sort of managed to limp into port. But yes, there's definitely evidence you can get waves that high. They don't last for a very long time, but they do occur.
Thank you very much. If you're enjoying Ask the Naked Scientist, then you might like to check out The Naked Scientist, our regular roundup of the world's best science. Each week we take a look at the latest science news, talk to top researchers working at the coalface of discovery, and also get our hands dirty with a science experiment that you can join in with too. So make it a date and prepare to strip down science on the web at nakedscientist.com/podcast. Pat in Lowestoft says, Dr. Dave, since last night my wireless has gone very distorted. It sounds terrible. Is it because my radio's packing in, or have other people got the same problems? Why would radio distort, Dave?
It depends what kind of radio you're talking about. Basically, radio works by you've got a transmitter. You send a big electric current up and down, which creates things called electromagnetic waves, also radio waves. It's the same sort of thing as light. and then these travel out from the transmitter. And then you have another aerial. You get a little current running up and down that aerial, which you can then have sensitive detectors in the radio to work out what's going on. There's all sorts of things which can distort radio. And if you've got a normal AM thing, it normally comes over as a hiss. So if anything's transmitting radio waves itself, then you can get lots of hiss on things. So if any electrical equipment is transmitting lots of radio waves, motors are notorious for it, then they can be their own radio transmitters, and they interfere with the radio transmitter you had to start with. Depending on what kind of radio system you're using, how that manifests itself can be different. If you've got FM, it tends to work. It sounds very, very clear until all of a sudden it sort of fails to work anymore, or suddenly it degrades very quickly. And digital radio is even worse for that. There could be interference from something which is transmitting itself, or it could be something to do with a reflection, or if you have a reflection which exactly cancels out the radio waves from your radio station, then you won't be able to hear it either.
Oh, it could be tuning even, Pat, couldn't it, as well? So sometimes,
Sometimes when people are doing maintenance on transmitters, they turn the power down because the poor guys who are climbing up and down the aerials they prefer to have lower voltages, which are less likely to kill them.
Scary stuff. Now it's time to go to the phones, and we're very pleased to welcome onto the show, as always, a man who asks the most interesting questions, and he's fascinating and lovely with it. Good evening to Tony.
Hello, my darling.
Hello, my darling.
I've got a little query for Doc about warming, global warming.
Yeah.
It will eventually unfreeze methane if it goes on.
Yeah.
How long do you think we'll take to do it? And do you think it ever would do it?
Yeah, I think what you're talking about is methane clathrates.
That's right, the one that's in the sea.
Yeah, this is where deep in the oceans, under high pressures, you can get ice form. You can get a structure where you have something a bit like ice, but because ice has got quite a sort of gappy structure, there's quite a lot of space in it, and you get methane locked inside this ice structure. And they tend to form where at the bottom of the ocean, sort of in the sediments, where you've got something which is rotting and producing methane, and then it gets trapped inside the water because of the high pressures, and it will sit there for thousands of years. The thing is, when it heats up, it can start to melt, and the problem is that methane is a greenhouse gas which is about 200 times more powerful than the equivalent amount of carbon dioxide. So if these start melting, then it's going to increase the rate of the greenhouse effect kicking in. I think there is some evidence that there are more of them going off than there used to be. It's quite hard to tell because you've always got to be there at the time to actually see, because what you tend to have is a little earthquake or sort of a little landslide at the bottom of the ocean, which kind of reduces the pressure on one of these. And now it's warm enough for it to melt. All this gas can suddenly escape when you get the ocean bubbling. People think that this might be that you also got these at the last climate optimum, which was around about 1000 AD, when the Vikings were rowing around in Greenland and living in Greenland. And they had lots of stories of maelstroms where the ocean would go very oily and kind of very strange and choppy, and ships would get lost in it and sink in it, and flames would go out and things. Because if you have an ocean full of bubbles, the ocean now isn't as dense as it used to be, so your boat, which was light enough to float on normal water, all of a sudden it's not light enough to float on this bubbly water and it can sink. So there's some evidence that they were going off during the last climate optimum, and I think there is some evidence that they are starting to melt now. Whether it's enough to having a big effect on our climate yet, I haven't seen any evidence for, but it could definitely be quite soon.
Tony, thank you very much indeed.
It's right, yeah. If I don't see you before, happy Christmas.
Happy Christmas to you. Thanks, Tony.
Bless you.
Thank
Bye.
you. Bye-bye. Right, one here from John who says, Dr. Dave, what actually triggers hibernation in some animals?
Talking of things that I don't know, I'm afraid I think that falls into that category.
Does it?
Don't know, I'm afraid, John. You probably have to ask Chris or Helen or someone with a more biological background. I think lots of biorhythms are triggered by all sorts of things. I mean, we have things which are triggered by how long days are. Lots of birds and things will start singing when day lengths get to certain lengths. Others will do it by what the temperature is. I wouldn't even be sure that it was the same for all animals, because some animals and plants trigger what they're going to do by day length, others by what the temperature's doing, others by some complicated mixture of the two. And actually, this can be very important to an animal if the climate's changing.
Yeah, absolutely.
Because if you're if you're hibernating and you're asleep, and you're working on the day length, or you're a plant which only starts to sprout up when the day length gets longer than a certain amount, but the world's a bit warmer now, and there was actually a month when you could have been growing away frantically, and everyone else has been doing it, then you're not going to be able to grow early enough, and you're going to get shaded out.
Or like crocuses, that come up on lawns and things, and then somebody comes along with the mower because they think they ought to cut the grass. Now, Rick in Whittam has called in to ask you, Dave, why are all the planets round? Good question.
It is a very good question. It's basically all to do with gravity. If you imagine, basically gravity means that all objects, anything with mass, attracts everything else with mass. So if you've got a load of lumps which are going to make up your planet, they're all attracting each other. And they're all trying to get as close to each other as they possibly can, as close to as many other massive things as they can. If you imagine a planet which started off kind of like a big, long, thin, dumbbell-shaped object, then it can actually get the objects inside it can get closer to each other by kind of squidging and getting a bit less dumbbell-shaped, and getting a bit less dumbbell-shaped, and getting a bit less dumbbell-shaped, until eventually you get to a sphere. Because that's basically the shape where everything inside it is as close as you can possibly get to everything else inside it. Any kind of projections above that, things can get closer to everything else by falling down, by coming closer to a sphere again. The Earth isn't quite a sphere because it's spinning. So centrifugal force is kind of throwing out the centre a little bit. So it's sort of like a slightly flattened sphere, but it is very, very close to one. Yeah, I think... Yeah, it's far smoother than if you actually kind of scaled it down to the size of a bowling ball. It would actually be far smoother than a bowling ball or a snooker ball.
They're all out there, nice and round. Ralph in Stamford has called in to say, how is it possible for there to be a volcano under the sea? Very good question, because surely water would put out the fire. And I think it was last week we were talking about, that how do we know that the centre of the Earth is so hot? So good question, Ralph. How is it possible for there to be a volcano under the sea, as surely water would put out a fire? Dave?
Yeah, water does put out a fire, and it will cool down lava coming out of a volcano much quicker than air does. Basically, a volcano occurs when you've got a load of molten rock underground, which is under pressure. It's mostly under pressure because it's slightly less dense than the rock around it. It's trying to float upwards, and if you've got lots and lots of molten rock underneath it, the force pushing upwards can get so great that it can split open the rock above it, and then it can sort of ooze out a bit like toothpaste out of a tube. And so it's not actually on fire. It's not burning at all. It's hot. The lava coming out of a volcano is hot just because it was hot before. And some volcanoes can be very, very hot. In fact, most of the volcanoes which occur under the sea, the lava's coming out at about 13 or 1400 degrees centigrade. So basically you've got incredibly hot rock under huge pressure. Now, if that rock comes out on the land, especially it tends to be, if you've seen any pictures of volcanoes in Hawaii, it's really, really, really hot, runny lava. Yes. It kind of guts up to the surface, then it takes ages, hours, days, months to cool down. So it will kind of run down the sides of the volcano. It'll still stay liquid for definitely a couple of days. So you can have big vats of molten lava and big craters which stay there, bubbling away, and then it have a big eruption. It will sort of run down the side of volcanoes for miles. A volcano in the sea is very different from that. In fact, because it's being cooled so quickly from the water, it tends to kind of come out in little kind of squidges. It's sort of like a little earthquake. It is very, very like toothpaste getting squidged out of a tube. And you get like sort of little things which look like pillows, like rock pillows. They sort of squidge out of you get squidging out of a little gap in the rock, which the lava squidges out. It cools very quickly, so it kind of gets extruded out into a kind of rounded pillow shape. And that bit sets, and then the pressure builds up again, and it's squidges out somewhere else, and you get another rounded pillow shape kind of being extruded out. It builds up thousands, millions of these pillow shapes.
Right, yeah.
Actually called pillow lavas. Very imaginative geologists when they
Yes.
come up with their names. And so it does affect how a volcano erupts very seriously. And so the lava doesn't go running around the place because it's been cooled so quickly, because there's water's basically much more dense than air. And as it comes out, you get lots of water boiling around it, and it's quite impressive. People have gone down there with cameras and taken some lovely video of it.
Is it on YouTube?
I'm sure it is on YouTube. I haven't looked myself. But yeah, it does have a big effect, and it does cool the lava down much quicker than it would do on land. But it's not enough to cool it quick enough to stop it getting out.
So it is possible. A text from Kay who says the speed of light, 300,000 kps. Creationists believe the universe is 6,000 years old. What speed would it have to expand at to get to its present size? Oh, Dave, I can see your wheels whirring already.
Yeah, I mean, the universe is expanding very quickly. It would have to be to expand from a point to the visible universe that we can see now, which is about 14 billion light years across. In order to do that in about 6,000 years, you'd have to be expanding at maybe 2 or 3 million times the speed of light, which wouldn't be possible.
All right, interesting stuff. Mike in Colchester very quickly says, does gravity gradually draw the moon towards the Earth, resulting in a collision of catastrophic proportions?
The moon is always being pulled towards the Earth, but the moon is moving fast enough that it always misses. This is what's called an orbit. The moon is always accelerating, it's always falling towards the Earth, but by the time it would have fallen and hit the Earth, it's actually because it's moving so fast, it's sort of actually just moved out of the way, and it keeps missing. In fact, it's missing so perfectly that it's always going around a circular orbit. In fact, the moon is moving away from the Earth because of the tides on the Earth, because the Earth is spinning faster than the moon.
Right.
The moon creates tides on the Earth of the water. It pulls the water towards it, and then the Earth is spinning underneath these tides and dragging these tides around with it, and that actually applies a force to the moon, which tries to speed up the moon. That gives it more energy and actually increases the size of its orbit. In fact, it's not so much that the moon will eventually result in a catastrophic collision, as you're mentioning. It's actually created by one. Because the present theory about how the moon was created is that something about the size of Mars collided with something about the proto-Earth, which was significantly lighter than it is now, slightly off-centre. So it smashed into each other, and then it's just off-centre, and they sort of span incredibly fast. This collision hurled lots of molten rock droplets out into orbit around this new planet which had formed. And then that slowly coalesced to form the moon. And this is the reason why the moon is made up of very low-density rocks, very like the continents on the Earth, whereas the Earth is much more dense than certainly more dense than other similar planets in the solar system.
That's it for this week. Our doctors will be back with me next week for more Ask the Naked Scientist. But don't forget, you can also catch them on the Naked Scientist podcast, which you can find on the Naked Scientist website, www.nakedscientist.com.
The Naked Scientists are sponsored by the Wellcome Trust, the EPSRC and UK Fast. For more information, look us up online at nakedscientists.com.